Okay, this is a polar free response BC calculus problem. They gave you r equals theta plus sine 2 theta, and the interval was from 0 to pi. So when theta is 0, r is 0. When theta is equal to pi, it's actually equal to pi. And you got to remember when I'm over at pi, I'd be over here. So the first question was, what is the area of this curve, this here? And remember, with polar, when I sweep through an angle. So I start at 0, and I sweep the area going like that. And the formula for that is 1/2 r squared d theta, which you'd have to plug into your calculator and get 4.382. The next question is understanding the relationship between polar and xy. It says what angle has the x-coordinate equal to -2? So on the curve, it's here. I can ground you. But what I do here is say I know x equals r cosine theta, y equals r sine theta. So I would set -2 equal to r, which is my function, cosine theta. And you can use your calculator again to figure out that theta is 2.786. And does that make sense? 2.786 is getting close to pi. And of course, we would have been all the way around to here, which makes sense. Next question is making sure you understand what dr d theta. Before I get to dr d theta, though, the first thing, most questions with polar talk about dy dx, because if you're asked what's the slope of the curve at any point, you have to calculate dy dx using dy d theta over dx d theta, where again y is r sine theta and the x is r cosine theta. But here they're saying between pi over 3 and 2 pi over 3, dr d theta is negative. What does that mean? Well, again, they're testing your knowledge. Do you understand dr d theta? So what's going on here is theta changes over this interval. R is getting smaller, which means the curve is getting closer to the origin. And then D is another question in that vein. They're saying in the interval from 0 to pi over 2, what is the greatest distance from the origin? So again, you're looking at maximizing r. So I have to look at dr d theta, which is 1 plus cosine 2 theta times 2. Find where that's equal to 0, and that is at theta equals pi over 3, pardon my juggling here, which I calculated analytically. You could have used your calculator, but the value of r there is 1.913. But just like in xy, whenever you have a closed interval, you have to check the endpoints. When theta is 0, r is 0. When theta is pi over 2, r is about 1.571. So the maximum is at pi over 3. So again, a great polar problem, not too difficult. And the biggest problem a lot of times with the areas is knowing what angle to sweep over.